Okay, we are live. Welcome everybody to the final presentation of the Architectural Machines workshop. The Architectural Machine is part of the Digital Futures initiative. We have today as guest jurors Alessandro Zomparelli and Yanil Aleman. So I would just ask both of you to do a really short self-introduction for our participants. Alessandro, please, and then Yanis after.
Okay, hello everyone. I'm Alessandro Zomparelli. I know Alessio Rioli from university. He was my teacher, and then we continued to collaborate together as part of a Code8 team on working on different research. And since I don't remember how many years ago, I'm also founder of MOX or MHOX, and I'm working on the generation of basically 3D printable objects that can be wear on the body according to the finished scan of the body. And also recently I started to develop an add-on for Blender that is called Tissue in order to bring computational design workflow inside this software. And I'm glad to be here, and I'm quite curious to see the work that you have done during the workshop. I also had another workshop during the same event, so I'm quite sympathetic with issues and the limitation of the time. So I can see that the expectation is really great, and at the same time, the time for developing very complex project is not appropriate, but I'm quite curious to see what you were able to do during this short time.
Okay, Yanis, up to you.
Hello everyone. I'm very happy to be here as well to take part in this jury, and also very excited to see what you guys have been doing. So I've been knowing Alessio for I think 4 years now. We actually contacted him when I was doing my PhD to work together, and he accepted, which was pretty neat. So since then I've joined Code8, and we've been working together ever since. And so currently I am assistant professor in a school near Paris, in Le Mans. And we have a degree in computational design, which is, I think there's just a bunch of them in France. So we are mostly interested in computation and robotics. So really curious about your work, because I'm also investigating at this moment this notion of discrete assemblies. And I've been in touch as well with Alessio about the new plugin he's developing. So really excited to see your work, guys. Looking forward.
Okay, last minutes of introduction, and then we'll start immediately. I will just take the chance to recap briefly what was the aim of the workshop with the Architectural Machine. The intent is to study and expose the information embedded into assemblages made out of parts that are themselves considered as elementary units of computation. And so explore what are the results of an open-ended construction of a topological system on one side and an architectural system on the other side that go hand in hand. And yeah, hopefully you know that the guys have very little time to get their hands wet with it, but nonetheless, I think they will show something interesting on this side. So, without further ado, I would give the floor to Andrea and Saurabh. So you should be already able to share your screen. We'll do it like that. You're going to have a maximum of 10 minutes for your presentation, and then we're going to have a Q&A from the guests and myself. So floor is yours.
Andrea, your mic.
Andrea, you're muted.
First of all, the title came out from a from a book written by our dear uncle Oma, aka Rem Koolhaas, and we just as we developed a radical approach to this city of New York, we just opposed this name. So actually, is just to remind to everyone that we are working there in a radical way. So New York has taken as a testing ground for many experimentation, mainly in the 20th century, like Le Corbusier or Super Studio. So we took this occasion to develop something on a urban scale, on a very big urban scale, trying to create this superstructure that has been able to flow around this part of Manhattan, actually the arrow of this island, with a module based on a flat scale. So actually this is following a specific path line and a bounding box that we created, taken as an example of the Super Studio shape. And actually this is fitting on the top of the building or in the water, and at the same time also in a free area of this part of Manhattan, respecting the pre-existence and going around and never colliding with it. So as I said, we developed this superstructure following two things: a vector field direction, vertical for the legs and horizontal for the upper displacement, and a 3D complex polyline for the main direction. And these were the three main modules we used, two for the main development, and the last one is the post-production element. We just baked some ceiling, some vertical closing to this enormous habitat. Actually, as you see, we reached almost 9,000 elements, so actually it's a quite big structure. Before everything, actually, we selected a very specific heuristic. Right now, because of its vectorial, is not charging, the line weight, but the heuristic we choose are as a thicker line. I don't know if you can see on this element table. And actually all of them had 4 handles to develop, and as you see, the heuristic is quite short, but it was still able to develop this kind of structure. And we also work with cone void inside the structure to let the rains and sun to pass through, or at least to get in, as the density sometimes was too much for the inside element. And these are just views that let you understand the scale of this module and in general of this superstructure. Actually, all the cubes, the starting element was a cube that has 4 meters per each direction. So that was all, and this is the final video, a fly through around this beautiful city. Actually, because of time problem, we were not able to develop a better video with music, sounds, effect, and birds flying, but we still like it.
Okay, thank you very much. I will just start with a question before leaving the word to the guests. can you please tell something about the logic with which you decided to add the extra geometry to the assemblage? Spend a few words. I mean, I know for time restriction, maybe there was little time to
actually,
prepare slides for that, but yeah.
I think Sarab is better than me.
Yeah, I mean, you're a team, so whoever wants to speak is welcome.
All right. So we placed a rule that we wanted to place only the post-production elements based on the directionality of the component that you selected. So for example, right now we have those placed only on the, I mean, I can't really use my mouse and show, but only on the right side corner of the component A, and also the right and left side of the component B. And the rule was based such that only on the horizontal components, we will have some kind of enclosure. Yeah, perfect. And the vertical components stay open. So this was the only post-production rule that we managed to apply at this point. The other intention was to cap the tops based on their position on the curve that is running through the heart of the city. But that is still under construction. We are not quite able to get to the point where we apply it on the superstructure.
Okay, thank you very much. I will then just leave the presentation up in case you have any more questions or you need to show something. I will just leave yeah, okay, yes. Keep on sharing. Don't stop sharing the screen.
Yeah.
I will just leave the words to the two guest jurors. So whoever would like to begin and say something, please.
Okay, well, very interesting work. I was expecting a completely different scale, so I was impressed by the type of project, and I think it's an interesting vision of a city. I wanted to ask more information about the strategy that you use in order to populate those modules inside that area. I understood that you are using a polyline for defining the specific area, but then you mentioned two vector fields, one horizontal and one vertical, if I got correct. Yes. And so one is affecting the generation of the vertical connection and the other one the generation of the horizontal. If you can elaborate a little bit how those vector fields are affecting the creation of the system. Okay, now I see.
Sorry, because in the presentation, the vectorial graphic has not appeared in a good way, but no, I think the image is explaining enough because I don't know what to say more. Actually, it's just like this. From the bottom, one vectorial field is going up till a certain level where the legs are starting colliding with the polyline, the horizontal part of the polyline, and then we change the direction of the vector field in horizontal to have a better development of this module as they work better in the upper part in horizontal than instead of vertical.
I mean, the intention was quite simple. That as you saw in the slide number, I don't know, like the initial slides where you see the context and the controlling points.
Here, this? No, here, this one.
The other one, the one before, I guess.
This.
Yeah, exactly. Okay. So the intention was simple again, like wherever there are like more neighboring vertical elements, so almost in the central part and around the legs on both the ends, we tried to apply the vertical directional vectors. So the feeling on the ground is more directing towards the z-axis, and the more you go on the flatter part, like let's say the whole bridge in a way, there we applied the horizontal one.
So on the superior part are only horizontal elements?
Yes.
Or there is still the contribution of both with different?
There is, of course, contribution of both, but we tried to place the rule of more horizontal on the super part.
Okay, so it's a kind of affecting the quantity of the percentage of different components that you have. I see.
Yeah, if I may intervene just to complete the answer and give information to the guests. The system can be affected in many ways. It grows iteratively, assembling one component after the other. but then you can affect the choices that the system make using scalar and vector fields. So the scalar field tries to place components in the field is of course distributed in a three-dimensional space. So with the scalar field, you try to place components as close as possible to the threshold value that you feed to the system. So you go for ISO values in the field or close as possible to those. And with the vector field, you try to select the component that is closer to the direction of the vector field in that point.
I see.
So
Really
placing a horizontal vector field means that the system, we lost Andrea, I think. Well, he will try to join again. Means that the system tries to comply as much as possible with this need for horizontality, but it doesn't mean that everything will be horizontal. That depends also on the rules that the system has for growth. Okay, just to complete the picture of what they have to do.
No, now it's completely clear.
Sorry, it was not intentional.
Yeah, no, don't worry, Andrea.
We trust you, Andrea.
Don't worry.
It's fine.
I think
it's a different project.
Okay. No, I think it's a very interesting object. We mentioned the time constraint that unfortunately we all had during this event, but I'm wondering if you see further development for this object, if you get some idea that you weren't able to do because of the time limitation, if you have some
many ideas.
Okay.
So the foremost thing was to constrain it on the topmost members. So I mean, right now at this point, all the members, I mean, the unit on the middle, unit on the bottom, unit on the top, they are just copied the same. We still want to filter out the member which is on the top to have some kind of special treatment. We're still trying to figure out what kind of rule we can apply for it. The rule that the distance from the from the curve that is defining the whole shape did not work quite that well, because it's hard to, I mean, it can give like the members which are up to certain extent, but not the topmost on each point. So yeah, that's one thing that we want to develop further. And apart from that, we would like to have more constraints in terms of the positioning of the legs. So it's not like a ballerina with a lot of legs, but yeah.
You mean the main connection with the ground?
Yeah.
Okay.
We would like to add more where it would be feasible. Like at points right now, it's sitting on top of the buildings or in a park. We would like to find out more opportunities. And at this point, it's also linear. Perhaps it would be possible to get it flowing in different points in the city.
Interesting. Thank you.
Thank you.
Yeah, so I think it's a very interesting and challenging work in a sense, because as Alessandro was saying, of the scale, of course. So I had a few questions. I wanted to know first if the kind of loop we see on the top left was intentional, or it was something that emerged from the growth.
The top left or in the center, you mean?
Go to slide 5.
Yeah,
top left of this slide.
Slide.
So I mean, when we saw the city as a whole from the aerial view, it was quite evident that this is the point where max of the high rises were turning out to be, and we wanted to respect the skyline of the city and go along with it than trying to oppose it with a low rise. Or yeah, perfect. In the elevation, it's very, very clear.
Yeah, but I guess my question is, so here in this slide, we see there's a polyline, which gives the kind of, let's say, linear orientation. So this I get, and I also got the influence of the different vector fields, but I don't understand how your structure evolved into this kind of arch in the middle.
Because it's a 3D polyline.
Ah, it's a 3D polyline, okay.
Yeah.
Okay, so maybe in this case, you could show an elevation of the polyline as well, because it's not extremely clear from me.
I could have done it, yes.
No, just an advice. No, that's interesting. It was just a detail. So maybe moving on to maybe something more about like your actual speculation of this. So in your images, you show something that is more in programmatic terms. It seems to be more like a kind of a massive housing project. But you're also referring to SuperStudio, which, as we know, there's a kind of absence of differentiation in SuperStudio project. But it's interesting because also in your project, you kind of achieve the maximum differentiation with like minimum number of elements. So I think I would like to know your position on in a sense, the kind of function of this building. Do you see this primarily as a kind of speculation on a massive housing system? Or do you see you could see it as a kind of a micro city embedded? What's your goals, maybe also for further development on this aspect?
I mean, the choice for New York is totally provocative, but in a near future, we are gonna end the spaces to build, and we're gonna be like 14 billions probably. So actually, we wanted to develop this kind of strategy in this provocative way, because maybe in 14 years we're really gonna need this almost favelas with a mathematical order, because that's what it could be. It helps you to develop a big scale elements in a. Okay, if you want to build it, it's gonna bear some major problem. But if you think on a scenario when you're gonna have population problems and not places where to place them, that was our provocative way to show it.
Right.
In terms of usage, we foresee it to have a strong character for residential and an office building at the moment, because no matter how dense it gets, it kind of is quite porous, and in the 3D view or in the perspective, it's quite clear how almost every unit is able to get from some or the other way. In this case, he's shown the rain falling from the sky, but I think the porosity is the strongest character that it retains even after being so dense.
Right. Yeah. No, this is interesting. I'm just wondering if you could. I mean, of course, understanding the limitations and this is already pretty impressive work for like a one-week workshop. But I'm wondering if you could achieve, like, let's say, further differentiation in some areas, maybe by post-processing of the components, to play on those opportunities that you have with porosity, maybe to have some kind of platform zones, or because I feel this project has more like potential as a kind of contained, living environment than as a kind of a massive housing system. So you could probably kind of try to embed more programs in a sense. So office housing, but maybe you could have, I don't know, kind of platforms or areas for circulation and try. And I know also, I guess you have talked with Alessio about tools to analyze the path, and so that could probably give some insights about how to develop that. But those are just like suggestions. Again, I think congrats. This is pretty impressive.
That's also a very good idea, I believe, for the further development of this project.
Yes, no, this could be a city in a city. This could be a self-sufficient environment that you can place everywhere. Probably also on Mars if you are able to build it, because it's the simplicity of the module let you build a complexity addition of function.
I think it's a bit in the SuperStudio spirit with, of course, very different kind of spatial paradigm, right? Like a SuperStudio is very linear, but in a sense, like SuperStudio, if you see this project, it's a kind of a plug over New York that like completely ignores, in a sense the seeds kind of goes around, and you're also doing it, but you have a very different paradigm. Instead of like, you have a paradigm of porosity, which one might say, but still you retain. I mean, and it's good you show this reference, but you could exploit maybe the theoretical part of this reference and connect it with like the issues we might face in terms of housing crisis and densification. You know, so I think there's also a lot to develop on the theoretical side of your proposal as well. So yeah, very exciting.
Okay, if I may pitch in, I think it's a very, very interesting discussion on the project. Actually, we didn't have very much time in the previous days to dig in into the, let's say, the premises and the intent of the project. Nonetheless, I would like to say a few things that are important before moving on to the next presentation. Guys, remember the distinction that I talked about on day one between unit and component?
Yes.
Because that's exactly the step away from modernity and all this. I mean, I like the references, but you have to understand that they are the past. No matter how radical, they are still a proposal rooted in a philosophical and architectural view that belongs to the past and that not to be resurrected. I mean, of course, you have to learn from it, but the fundamental step away is the concept that the modern had of the functionalized unit. 1 unit of space equals 1 function. In our case, what you are using are components. So what Yanis was suggesting is actually something that I would have suggested as well. So resist the temptation to assign already a function to that component from the very beginning. Look at because that's a component that's not just a modular unit that composes something that is made only of the same properties of the modular unit. When it combines, it creates spaces that acquire different properties because the aggregation is open. So even the qualities and the properties of the spaces that you are creating are open. And so they are open not just to see this as a massive housing or something, but something that could be entirely rethought in terms of even in terms of what you understand as function as related to your lifestyle. Do you really need exactly the same functional catalog of houses that was laid out in the 60s and that we still use, like living room, bedroom, kitchen, all done in the same way? Or can you discuss a different way that is more tied to a contemporary lifestyle, also to see what is the new thing about relations between work lifestyle and private lifestyle, even in the post-pandemic world, if you want to bring actuality into it. And looking at the spaces with a fresh pair of eyes, without the baggage of reading forcefully in a space the functional catalog of the modern into it, might give you a larger perspective on considering the potential that you have in your creation here. Okay, I mean, I think this reviews, the final reviews, is just a chance to exactly take these objects, take what you have done as objects of discussion, reason about it, and have a chance to add something to the perspective and to make it grow even more in terms of let's say things that it can say, or interceptions with other dimensions of looking at it. All right, well, guys, thank you very much. Before moving to the next group, look alive, because I will send everybody an email after the presentation on how to send me the final material, the final deliverables that I need to give back to the organization of DigitalFutures. I just wanted to add another piece of information for the guests. It's that the scale of the project is not going to be this one for all of the projects. I actually had something in mind with the beginning of the workshop, but then I prefer to leave the participants free to steer the instruments that they were given towards some more personal goals. So you're gonna see a different range of scales and scopes within the various projects. But I think it's also more interesting, and I was curious to see where this same approach and process could go if applied to a different range of scales and scopes in themselves.
Definitely.
Okay, so next up are Alia and Nora.
Yes. Okay, so
yeah. Share your screen, and the floor is yours for 10 minutes. Or up to 10 minutes. If you are faster than 10 minutes, we start with the questions later. All right.
Okay, so Nora and I had an idea of voids. Coming from the architectural scale of voids, we're talking here from designing not only from the outside, from the mass, but also from the inside, from the spaces which are coming between the walls, the interstitial spaces, or the rooms, or anything which is within. So as a reference, the Salk Institute by Louis Kahn, or wide-known language, parent language, seminal work of the Christoph Alexander, or on the art side, Haus OR from Gregor Schneider, which he developed to be of one layout on the inside and another layout on the outside, creating the void spaces between the walls and feeling of uncanniness being in the spaces. So we took from that idea of designing from the void and took on to experiment with components and heuristics. First of all, we thought, okay, maybe we will start with a component which will contain the void as an outer shell. So our first test was component A, which would create smaller spaces on this side and the bigger spaces on this one. And we did a heuristics test, thought maybe it will be better to create the second component B, which will work very well with the first one. Here are first connection rules that might have created these nice ideas, not only of the void spaces, but also the spaces which create kind of a window, a bit more Le Corbusier maybe style of looking outside and seeing through the whole perspective of the space, or maybe seeing that there is a dead end and making it even more curious. So our first assemblies look like that, based on the occupancy or the sequence. Then we came to the problem that it was a bit hard to define what is the circulation path if we're going with an element which looks rather from the typology of the slab. So we decided, okay, maybe we can create a negative form and is a form of mold and trying to create the voids from within. So we took the first component that worked for us, and then we inverted it, and we're looking at the different heuristics which came up, and trying with the environment in an urban setting, coming back to the notion of how these maybe parasite-like void spaces will actually fill the voids between the first and second rows of the houses, having the constraining box of the block and the obstacles as the buildings to move around. Yeah, then we tried the circulation curves within this block, but didn't find a really well approach that will work for us. Tried with a different analysis of the shortest path from one space to another of the different assemblies. And finally, we came to the final aggregation, seeing that we're taking the component A with the handles and the circulation path that we intended to have, and create actually a void or a box around it. So for our simulation of the circulation spaces, we used the box, or other known as a BB or bounding box component. And for the visual aesthetics and seeing how the space will look like, we took the component A. So it also brought some challenges. So for the first, we took the heuristics of the component A, manually picked the ones that we thought that would be interesting to create nice spaces. And then we translated that to these bounding boxes. From here, you see that it is a bit hard to define or determine which ones will actually create something valuable. From here, we went further to the environmental space and tried with a different assemblage to see how it will behave on a smaller scale as a house, or in a bigger scale as a part of the blocks, or something in the middle. And analyzed that finally the difference between the free handles and included handles is also, it depends on the surroundings. So here, if you have more houses around, so more of the handles are free but actually occluded. Yes, so here are assemblage number 1, 2, and 3. They are not iterative, but that would be also interesting to see how iterative approach in the assemblies of these building blocks will look like in the future, or maybe and other constraints of the urban environment. Here is a short GIF of the options. And then for analyzing how actually the connection between these void spaces will function and will look like, we came back to this component BB, taken with the same heuristics and the same assemblies. We looked at the circulation paths connecting the points in a length, the extremity points of each of the boxes. So here are 3 of the examples, how it looked like. We found it actually super interesting and would be very excited to continue working on that and seeing what we can do with the spaces. Yeah, and here is the views from the inside, how that might look on a scale of the person. Some spaces are super big, some are more narrow or smaller. Maybe that would be interesting in the creating an impression of vastness versus the pressurized environment. And here is how I would imagine that to see when somebody is passing by and sees this enormous structure. Maybe it could be covered with actual facade, so you don't see what is inside, and only when you enter, then you come into this Alice in Wonderland style labyrinth. That's it. Thank you.
Okay, I will turn the floor immediately to the guest. So
you want to go, Yanis, or I go?
I can if you want. Yeah. Okay.
Okay.
I'll be quick. No, so thanks for the presentation. I think it's a very interesting idea to start from the notion of negative space, and I really liked also your idea to think of components as positive and negative kind of duals, right? So that they can kind of work in team. My question is more about the workflow you eventually choose. And my understanding is that you're generating, like you're setting the heuristics exploration with kind of your final components, but then you go to bounding boxes and you make the assembly with bounding boxes, and then you go back to some kind of component. So I mean, could you maybe elaborate on this part where you introduce the bounding boxes?
Yeah.
Yeah. And why eventually did you choose to do that?
Eventually, we faced the problem that we wanted, because we are creating from the inside to the outside, from the void, we wanted to also see how this void will be connected and which circulation path or exploration path it will do. But in the current set, it was not, the script was not working on a slab mode of the space. That means we could only do the circulation path. I think it's on the next slide. Here, on this. The circulation space would work only if it goes from handle to handle, but within the surrounding box. And if we're going from the component, which looks like generally like a slab, and the handles are more in the space, it didn't connect the way that we wanted to. So we did the work twice, that we did the assemblage with the actual form that we wanted to, but to analyze how the people will be moving in, we had to have this bounding box to see that. But this is actually a super interesting thing that I would definitely like to see how it will develop, how when we have something which looks like a wall or a slab or this weird element, which is more flat, how the circulation lines can be adjusted or how it can be put in the space according to this element. So this was just a technical restriction that we had to follow.
Right, but in this case, my question would be, why didn't you start with kind of bounding box modules, explore the heuristics for these modules, and then after, like, replace them based on the circulation with more like slab-like elements? Because I think what is not clear to me, and I don't really, I mean, the way I understand it, and you can correct me if it's wrong, that you generate heuristics for kind of hollowed forms, and then you move to bounding boxes. But would it be more, I mean, it probably would, I guess, to also kind of conceptually and also technically to explore the heuristics with like the full elements, and after, you know, to hollow them, like, or introduce a differentiation.
But then you can't expect
what
it to look like.
Hmm?
We had it in one of our presentation here. If you work with the voids only, then you don't actually see how the connection of the parts at the end will look like, and if the form will be aesthetic or not, and in the way that you imagine it to be.
No, but especially I'm really referring to starting with working with full elements like this. But it seems to me, and maybe I did not understand it, that you didn't do the heuristics exploration with this type of elements. Like, you did them before with the kind of slabs, and after you put some bounding boxes.
Yeah.
So my question is, why don't you start with the boxes, explore the heuristics for that, which is also safer in a way to handle collisions and things, and after kind of replace them, you know, with some elements. And you can always have some kind of do some kind of simulation with small numbers to see how that would be connected.
So coming from the void, our intention was to use the one on the, if you go to slide 20, again, we had more interesting iterations with the aggregation of the element component A. So if we use the same heuristic for the bounding box, but then if we analyze this, we could not come up with interesting kind of connections. So that's why we choose to start from this, to see how these two components combined would actually build another space in between, and then move on to the bounding box, because the bounding box was just a technical issue actually we had to follow in the end. So if we would have chosen from the bounding box the connections, I think you see this on slide 20, one. Yeah. The combinations for this one, for the two bounding boxing, they were just like, I don't know, not interesting enough for us. So that's why we got back and forth in the end.
But can't you have like connection issues? Because if you don't, and that would be my last, I think, point, because I want to leave the floor to Alessandra as well. But I mean, for me, I think I really understand the process, and that is really related to your idea of like working with positive and negative forms. But I find it somehow I think there could be some issues. I mean, intuitively, if you kind of take the heuristics that are computed and pre-selected with some kind of lighter elements and keep the same exactly heuristics for the bounding boxes. You know, I don't think it's a very, I mean, it will not always work in my understanding, because the way the system is working is also making like removing the parts that don't intersect. But because those parts are much lighter, if you go with the bounding box, you could have intersection, I think. So just, I mean, it's just I think you could keep the same idea, but maybe, you know, I think it's also related to the way you work. So you started with this initial idea, then you faced an issue, and then you replace them with some kind of bounding boxes. But maybe now that you have more time and you can actually take a step back, and don't start with like the hollowed element, but start with the bounding boxes. Of course, you know very well that you are going to end up with the elements. But maybe this, you know, sometimes you also need to kind of restart from like a fresh state with the new strategy. And in this case, and that could also, you know, provide another direction to also develop, because you could keep this idea of masses, right, that you carve from at the end, but they maybe don't have to be like parallelepipedic shapes. They could be like L shapes or this kind of stuff, but you would keep the capacity to analyze. So, I mean, that is just a comment, but I think it's an interesting approach, and would be interesting to see how you develop that, and you know, connect the intuition you had of a duality in space with also the kind of duality you can have in the algorithm, in terms of like the components you use for aggregation and generating the connection logic, and ultimately the components that will provide the final spaces, right? So this is interesting, I think.
Thank you.
So yeah, maybe it was not the ideal way, but we were just looking from day to day, developing new goals every day.
Yeah,
so that's, yeah. But thank you for your comment.
I think Alessio has, we will have probably more kind of, or Alessandro more kind of insightful things about this. But I feel if you were to redo it, you would start from the like heuristics in the bounding boxes.
Yeah.
And
we can consider this for next week. So
yeah, probably. Okay, thank you.
Alessandro, I leave it to you.
Okay, thanks. Well, also for you, I think the project is really interesting, and it's kind of complementary according to what we mentioned for the previous project, because the porosity that was emerging from the other project was a feature that emerged at the end while you started the thinking at the porosity. So I think it's an interesting approach. And also the interesting topic that I think you try to approach is what are the performances of this system once you create the assembly. And so it's interesting that you try to find some layers of information that you can add to your module in order to have like a map, or basically a map of the path or the voids or the slabs, in order to have different layers in order to understand what is happening with a project. I think that the complex thing in both the project and I think in general in this kind of approach is to evaluate at the end the result that you get, because the object is really complex. You have many different conditions and it's quite difficult to analyze all of them. So I think that you started to work in a direction that it's quite important, that is understanding the emerging properties of a system that you're building. And probably it wasn't enough, but I think that the direction was correct. And I'm wondering, and don't have any solution, by wondering which could be some approaches that can help understanding and have some feedbacks of what is happening. I think that in this kind of process, it's a quite crucial aspect in order to evaluate the quality of the result that you're building. But yeah.
Yes, I totally agree. That would be the next step, also to analyze more in depth the circulation path, if it works or not, and different aggregation, radiation.
And I mean, it's interesting that you added the layer to the component itself, and somehow this gives some information. But at the end, probably something else should happen in order to make an evaluation that consider also some possible emerging effect or behavior.
Of course.
Yeah, I mean, that's a very interesting topic. They had some bumps along the road, so they had to go back and forth quite a while. So this is why let's say the appearance of the final level of development might appear, let's say, a little underdeveloped compared to what we've seen before, but the process and the intention were always focused and spot on all the time. I won't go into the questions that Yanis asked, but to me, there is still a bit of confusion in what you did with the bounding box, but let's not just talk about it right now. I think that the interesting thing in your project would be exactly that challenge we were talking about between yesterday and this morning, which is how do you, and it's a challenge that it's really, really difficult, which is how do you capture emergent organizational qualities when you start building up. Means recognizing semantic categories that do not exist yet in a few words, in a bunch of words. So how do you do that? This is some material for, let's say, high-level unsupervised training of machine learning, for instance. So that's why, remember yesterday I told you that's a different category of a problem. It's a different class of problem. This is what I meant. I mean, unless you can, unleash this kind of machine learning from the tip of your fingers at will, that requires a lot of, I mean, it's a full, draft for a PhD research, if you want. That's the kind of class of problems we're talking about. We're trying to find the circulation that your component engenders when it creates assemblages. But yeah, with a simplified version of the problem, there is something that can be done, building a line network and then working in trying to do something with that line network. Also introducing feedback aspects. This is actually one of the things that I would have liked to have fully developed before the beginning of the workshop, but I couldn't, unfortunately. But I think you already had enough on your plate to work with, still with the strategy that we have explored together the first 2 days. So I think you were going in a very interesting direction. Now, coming to mention it, seeing the slides of the Salt Lake Institute, it's just like a last minute thought, but maybe instead of something that is that open, another possibility would have to be to work in recursive pockets of voids, like a component that contains a pocket that has another void inside it, and see how you can reverse the situation between inside and outside, designing the component in a certain way, so that whatever is the outside for one becomes the inside of another when assembled. Well, just a passing thought, but all in all, I think, yeah, we've done a good job. So if any of you has to go, I think it's 4 o'clock, just remember to keep an eye on your email by the end of the day, because I will send you the instruction on how to send me the final material. Okay, but for now, yeah, good job. And I think I would like to move now to the next group presenting, which is Wei.
Okay.
It's a single effort. Wait, okay, Wei, you're
Yes.
here. Okay, perfect.
Yes. I'm going.
So yeah, share your screen and floor is yours.
Okay. Okay, I'm trying to. Okay. Can you see my screen?
Yes, yes, we can.
Thank you. I'm gonna present. Okay. Hello, everyone. My presentation and my project title is Puzzle Valley, and of this workshop, and it's
about 4 parts, and each of them you can see from the each slides they have from the right side they have the pages numbers and welcome all the comments. So first one I'm going to describe and extend my inspirations. So my inspirations is from this I will say this 3 art and also these 3 projects. And you can see all of them have the stairs communicated with the platforms in each layers. And the stairs and the platform, they combine together in different angles. And so that they can to guide into the everywhere and outer space with the inner space. So then it's my diagrams. So first I will start with a component I made. And from that 3 artworks, and I trying to find what is important elements from these 3 artworks. So I found one is right angle walls, pieces of the walls, and another one is the stairs, which can be connected to the walls in different angles, and they connect together to make my, this made my second component. And they collected together, as you can see from the right-hand side. Yeah, this is a possible single place which made with walls we just see and the stairs. Let me move to, okay, now you can see the page numbers. And so the you can from this small single models to see the scales with the humans and also the stairs. So, hide. Okay, I'll hide. Okay, so this is a large scale of the of my project, and with stairs and these walls, and you can see this is not as better as I expected, and also is I would like to say due to the time limitations, so it's not looked so better, and some of them may not look at as the what I expected. So next one is post assemblage analysis and operations. And I just analyze, actually we start with analyze the connections of each parts. I think I met the same problem with alias groups, but but sadly I cannot figure out the so well solutions. So the analysis is finally they are failed, but I trying to do the other works to make this in this project. So the last one is renders and short animation. I'm going to. Okay. Wait a minute. Okay. This
Okay. Yeah, leave the presentation on. So thank you, Wei. Thank you, Wei. Word to the guests.
Alessandro, you want to start this time?
You want to start? I start?
Oh, go on, yeah. Alessio.
Okay. Okay. I think it's interesting. You work alone, so I think it was even more challenging for you. I'm wondering, because you start from some images that were more related to artworks, and they are inspiring, I see. But in the same time, I'm wondering exactly which, which property you want to reproduce starting from those, because I see that those images, the one on the left is quite similar maybe to the density that you get at the end, while those are quite more open. I'm not completely familiar with the method that those modules are following. So if I get correctly, but maybe I'm not, you have some object, and then you can define some side that can be connected with something else. Is that correct? Okay, so maybe because you started with very simple element, maybe when we start to assemble and replicate, they may occlude a lot the space that you have. So I think that at the end, we see this quality in the final object that you have. While, for example, the group that we have seen before, they work with a bigger unit, and these have to have these more voids and more space inside. So I'm wondering if this property emerged, or it was something that you were looking at, because the reference that I see here, it's more open. You have more space, it's more light structure. So I'm wondering if you wanted to over-occlude the space, or if it just happened because you didn't consider properly what would going on with the repetition of those modules.
Okay, I totally understand it, and I would like to answer it is true that you mentioned that these three artworks, they are quite open and is easy to view from the outside to the inside. But I would like to edit more in this explanation is that from this three subject, I can see that the elements of like the walls, like the platforms, and like the stairs, how they work together to connect the space. So that's I think is what I'm just thinking about how to connect its space and make the space more flexible. Yeah.
Mm-hmm. Because if you can go to the slide 6, I think. So if I get correctly, this was kind of an expectation, how you saw those modules working together. But at the end, we worked a bit differently. So I'm wondering what would be for you a strategy for trying to achieve more this kind of result rather than an over-occluded space like the one that you got at the end. I mean, do you have, for example, some ideas in order to improve or develop further the design of your system?
Yeah, that is, I think, is this possible single space is more closer than the large scale models that I currently make this picture. So I think this one is more closer to my I can see my concept is like the space which can be connected to the open space and also have the closed space or private space.
Okay, thank you.
Thank you.
Yeah, so I think I would follow on what Alessandro is saying. I think it's an interesting approach that starts from kind of I mean, very artistic conceptions of space and also, I would say, orientations. If you can go back to slide 7, I think. Yes, thank you. What I think is also interesting in this is how some, and that, I mean, that's related to what also Alessio was saying with distinction between units and components. Some components that might evoke like stairs, you know, in terms of typology, you know, at the end in this kind of assemblage, they also become like column-like elements. And so you have some emergent qualities that are interesting and that could be really exploited. But then it's true that you have a very compact organization. So following up on Alessandro's question, I was wondering if the fact that you have a kind of sphere-like, you know, shape was something that was intentional, or is it something that you would like to change, introducing strategies like a field or some kind of guides to develop the assembly?
Well, I actually I haven't considered this concept quite details, but your comments and your questions just remind me about it. Well, I think is I think this large scale model still need to further development. As you can see, the stairs is not very clear enough. Actually, it's I'm trying to using these components to make a space or a like the kind of or maybe the space can connect it with the stairs, or also the stairs maybe sometimes can be the wall, can be the roof, and in this large scale model.
Yeah, but I think you could also try to explore those, you know, those opportunities of like recombination of a single component in different scenarios and orientations. Also, if you were exploring like different, let's say, massing to say it in this way, approaches, right? So if you were to find a way to kind of constrain your assembly growth at a more like kind of a planar or horizontal level, then you could also, at least visually, also investigate these opportunities, because you would see maybe 3 levels, you know, of connections and things like this. So even as a kind of a strategy, it can also be interesting to try to, I guess I don't really know exactly how the system is working, but to have set kind of different conditions, like maybe this one is very compact. Maybe you can try to see what happens if you have something that is very flat and linear. And then you can, of course, have your intent and develop that into something. But as a way to guide the work, that can probably be interesting to explore your system in a more like linear or on the opposite, completely vertical, maybe. I don't know. But there's definitely potential for sure.
Yeah. Personally, have you finished, Yanis, or do you want to add something else?
Go on.
But personally, I think, why did you change the components that are in the video? Because the one in the video are slightly different from this ones, right? Am I correct?
Yes, I have changed a bit.
Okay. No, I think that it's just a matter of an issue of time. The fact that you didn't update than the previous part, because what you show in the video is an even more simplified version. So the stair is not curved anymore, but it's made of a very simplified blocks, and I think they work a lot better than these ones. But if you show the video, just a still of the video, freeze the video in the middle so that we can see part of the object. Can you show the video? Because we are still seeing the presentation.
Yeah, of course.
Yeah, stop. Yeah, right there. It's okay. It's okay. Even here, it's good. Yeah, maybe not where you have the blur, the motion blur effect, where it has a little bit more still.
Okay,
But
I'll try.
no, but it's okay. It's okay. It's fine here. It's fine here. What I wanted to say is that since you took out the curvature and made larger blocks, remember the thing we were talking about, how this element, instead of being functionalized from the beginning as a stair, it's a generic element. And when you orient it in different ways, it starts working with different, let's say, starts to emanate different functional possibilities. So it becomes part of the structure when it is laid out vertical instead of horizontal as a typical stair. Or if you look at it from underneath, it looks like, again, part of the completion of the whole structural object. I think that the kind of spaces that you're getting in this video are a huge, huge improvement from the initial hypothesis that you were showing me just 1 day ago. I think you realize that too, right? I mean, the result speaks for itself, at least to me. This one, I think it's just a matter of now trying to adjust or have a little bit more time to work on being more selective with the rules that you're using, the rules that you pick out from the heuristics. But this is going on a very, very interesting path, I can tell you. Because then you stop seeing the stairs at all. You just see an object with different, let's say, self-ornamental characteristics that are both integrated with space and the structure itself of the object. So the components here are disappearing completely. There's just the object, which is very, very interesting, I think, because if you go to slide 7, even if you take away the edges from the visualization style, you still have the impression of seeing, okay, that is made out of 2 things. But if you see, if you show this to somebody and say, okay, how many parts or many components are here in this object? I don't think that they could pick 2 as a first choice. Maybe the first answer would be, wait, it's made out of components. It's not just a single thing, or it's not just models. So that's one of the goals that I hope you could see with working with the strategy. So looking at the whole as something that is made out of the parts, but maximizing differentiation by means of organization alone, then you have the possibility to let something more emerge out of the whole. And I think something that is there in this, in what we are seeing here. So I think that all in all, this is a very good effort. So if you mean to carry forward this sort of exploration, I would encourage you to do so. Then on the circulation, that is the problem I was just talking about with Ali and Nora. So when you start from the beginning with a component that is in itself a component that is a spatial unit, then you can be modular with how the component manages circulation. Because you have a space, you can know exactly where you can circulate. But when you use a constructive element as a component, you have no control on how the voids are formed until you see the assemblage in the end. So you just cannot, or it's very hard to do that with a network of lines alone. It would be a very, very big effort in terms of designing the handles, designing the connections so that you can actually predict all the possible connection points that the lines might have. But this might drive somebody crazy, I think, if you approach it from that kind of perspective. But still, it's a very interesting problem how to make sense of the spaces that you build, the circulation, how to analyze them. I mean, you can, of course, as the video shows, you can experience them perceptually. Ideally, what I would like to do, if the technology was as fast and distributed as possible, to immediately immerse oneself in a VR simulation of this. So you can go really inside the object and walk inside it and experience what it is like to see this thing at the architectural scale from a visitor's perspective. The next best thing is to either try. I show that you published this also in Modello. Do you have also this in Modello? This one? Not just a single unit. Do you also have this assemblage that we are seeing in the video? Did you export it also to Modello? Yes, I see you. I see you saying yes with your head, but I can hear you. Wait, did you put this to Modello, right?
Sorry.
I've seen that you had a Modello link in slide 6 for that little unit there. Did you upload to Modello.io, the website for sharing the 3D models through the web? Did you upload this one too?
This one not, just uploaded the single one.
Okay. So yeah, if you, I would maybe ask you to upload this too as soon as possible, so I could visit it. It would be very interesting.
Okay.
Okay, so
I can upload it later.
Yeah, don't worry. There's no hurry for that. I will send you all an email with because the rest of the material, the compulsory material, I need to have it by tonight because I need to send it by tonight to the DigitalFutures organization. I think, Alessandro, you're in the same situation.
Yes.
Because they asked you like for 4 a.m. tonight, Italian time.
Exactly.
Yeah.
I wanted to say that I agree with you about that this model is more interesting because of the property that you just mentioned. And I would be very curious to see what's happening inside. And maybe, yes, it would be great to navigate and go inside with VR software inside the object, but maybe just an animated cross-section would help understanding what is happening inside, because I cannot really figure out if is a space where people can live or if they're just stuck somewhere in some super closed spaces. So I would really like to see just cross-section that maybe it's very simple approach, but maybe can give also already some information of what is happening. And I think that in the other object that we have seen before, they were quite more porous and it was more easy to figure out what was happening. While in this case, it's really a question mark for me, at least.
Yeah, right. Okay, thank you, Wei, for your presentation. And then we move on to the next group, who is Alberto, Shermin and Alberto.
Hi, I'm going to share the screen. It's okay, it's working?
Yes.
Okay, let's see. Yeah. Okay.
Yep.
Well, hi. This is our presentation about our approach starting with patterns, but then it evolved to large-scale space station, which was the end of this process. So, well, at the beginning we start with the patterns because we're curious about how to work with this, how to understand the process in which it's possible to create it by simple elements, as well trying to translate from a 2D pattern to a 3D one, and then after that trying to find for which could be useful this idea from patterns to a three-dimensional space. So then we have our initial efforts. Can you see?
Yes, we can see.
Yeah, I was worried about the signal. Well, we started with trying to understand the aggregations. So we started with few handles, then we increase it, and then we decrease it as well. We change the rotation of each of them, and then we have these few unsuccessful samples that we have here. We have more, but these are few, in some ways, few significant, because one on the left is about the rotations, and then the other two were related with the amount of hangings. So then we were researching a little bit more about the highway behavior, which we started to emerge from our experiments. So then we understood a little bit more about what is. So it's such a kind of it's an aggregation trap into a cycle after some additions, and then it became such a kind of nice structure with a clear pattern at the end. So that linear pattern appears in our experiments as part of our process of aggregate and deaggregate more or less connections and handles, as well working with the angles. So this is our last heuristic sample in which at the end we have these two components. The one with such a kind of L shape plus a single element emerging to the vertical, and then the other one is like a smaller one, which is a T, with a connection embedded there as a lock. So then we developed several heuristics trying to achieve this collection, which is generated from the code. At the end we didn't erase any of them. So that was one issue that we developed. So all the heuristics were used for the final result. Then we started with this highway behavior, and trying to understand for what it could be useful. And then we discussed that it could be a nice idea to propose such a kind of a space station, which, you know, a space station is starting with a main root, and then with several arms growing from this main axis. So we started with 100 components to 1,000, and then the result was really nice in terms of that at the end we achieved this behavior of one main root, and then different branches emerging from there. Then we jump to a next level, trying to see how this from 1,000 can go even further to 8,000. And then it was a little bit dense, but it was really nice to understand that these branches at the end, they are populating the full space in a controlled way. So as well, we understood the diagram of components from 100 to 1,000, and then we realized that the T component was the component who developed the foundations probably of this station in the space, and then the green ones, the larger ones, were created the branches. And then from the branches, they're restarting new growing with these blue elements, the T components. So well, and this is really nice because at the end we have the animation of the system, and this final step, which was with 2,000, which was really nice in terms of the 3D dimensionality that we achieve, as well the highways emerging from this route. But sadly, it didn't work, the replacement process from the containers to the social kind of higher resolution elements. The heuristics changed during the process. So what is an issue that we can discuss later, probably. Huh? And then, well, here is an image trying to imagine this in the space and then a scale. Then the other one. So here are the, well, are emerging these highways from this main route, as well, trying to understand the scale of this space versus one spaceman there. And well, so kind of final animation in this space. So at the end, it's possible to appreciate the emergence branches coming from this main route as a space station, but in this different shape.
Yes. The challenge that we had was the angles, and we started with a simple pattern, but we understood
sorry,
that
we are still seeing the video. Can you please go back to the presentation?
Mm-hmm.
Because otherwise, yeah, go on.
Started with a simple pattern, and then we realized that the patterns are simple in 2D, but the 3D shape that emerged from them can be really messy and difficult, and it really depends on where and how we are putting the handles. So we at the start we had the problem that handles we put too many handles. And the results emerge a very messy in too many directions form that had on it. And our goal was to how we can control angles in emergencies. First, we tried to reduce the handles. Do you have my voice? First, we tried to reduce the handles, but the shape, the result emergence without the angles were very simple, and it wasn't what we wanted. That we wanted to control the angles in the emergent, in the emerged form, and we tried to use less angles and more in a very more thought way to kind of can manage how it not get so messy. And at the last stage, we understood that with certain handles in certain places in the first geometry, and a vector field, a horizontal vector field, we can so much bring reduce the chaos that that emerged from it, and it has a lot more to understand for us to control, but this is how and what we get in this time.
Yeah. Well, so at the end, thank you very much, and well, we need your feedback. Thank you. So let's see.
Thank you. I think it's a very interesting approach, very different from what we have seen in the other project. And I personally like two aspects in particular in your project. One is that you didn't define the function of a component, but you try to study the opportunities of assembly and the aggregation of those components before start thinking of what they could be. I think this is interesting because you, especially with emergent behavior, it's important to understand what are the qualities of the structure of the system that you get before start thinking about how to use that for your design process. And I think this is an interesting choice. The other thing that I like is that you didn't impose a general shape. And also for this aspect, you were more listening at the opportunities that were emerging from the system that you were simulating. So I think that was interesting to see that those bifurcation that you got, they actually came out from the process. And I think this is another interesting thing because then you can get some unpredictable opportunities in the design process that you are developing. So I think that this is a very interesting approach. I would wonder what could happen next if you had proper time for develop it completely. And yeah, also it's nice. Sorry for the noise. It's nice to see that you apply that to a space colony. And yeah, I mean, I think that the limitation for me at the moment is just the time that you had at disposal, because I would like really to see what would happen in the next steps. So I'm wondering if you are thinking of developing it further, or for you it's a complete project now.
No, I think it's for our own interest to see what's going on with this structure. So to understand if we can increase the resolution of the components, because they are containers at the end.
Yes. Yeah, really interesting work for me. Thank you.
Okay, Yanis.
Yes. No, I think it's very interesting also to see a different type of context and scale in a sense. So I was interested actually in there's two features that are interesting. One is like this kind of highway behavior. So I would like just a bit more details about that. How did you were you able basically to kind of provoke it and control it in a sense? And the other thing, could you just come back to, I think, a slide, the fourth slide or something like that, where you kind of start to have the gradual orientation. So it was before, it was in the bottom left part of your slide. You had an image where you had something very linear, and at the end you had some kind of angles appearing. Yes, this one, this image on the left. I think this one is also very interesting because it's much less orthogonal than what you have at the end. You don't really see too much like the intersection. So could you maybe say a few more words about this image and what's different in terms of, I don't know, setting up the handles and things like this?
This one has more handles in the angled parts, and different angles could join together at different situations that make these too many angles together. And the problem we had with it was that we couldn't control how it grows, and we want to experience the control over it.
Right, but at the same time, you have a kind of linear direction in this image as well. So is this because you edited some parts, or because after it becomes impossible to control?
It's around the curve. It's populated around the curve. That's because the way it's near.
Right. I think, of course, if you think of those components as probably like parts of like a station where you have some kind of circulation issues, like people would be able to evolve inside. This would be, of course, this would be challenging. But I think personally, in terms of pure kind of structure and kind of dynamism as well of the shape, I think there is something that is interesting as well here. So probably you could try to also explore that. Maybe it's a different project, but there is a potential, I think, here as well.
Yes, it was our last goal that we didn't have time to get it.
Yeah.
Yes.
All right. Thank you. Yeah, sorry.
No, it's something more. From our efforts, we detect this, the image in the right, we detect this highway behavior emerging a little bit. So then we decide to use a force field, trying to in some way promote some horizontal growing, and then we discovered that the highways emerging in a faster way.
How did you kind of lock the system into these highways? Is there some kind of strategy that you deployed with the rule selection, so you can have this kind of components looping and creating these repeated structures?
Yeah, was trying to be redundant in the angles and in the component A, or the larger the L versus the T1. So when we were redundant in the angles, plus the force field, with the redundance, this redundance provokes the highways.
And at the end, you have one force field or several force fields?
No, just one in horizontal way. Mm-hmm.
Okay. Yeah, that's interesting, because you have something that is more radial at the end. So, okay.
Because it's radial in some point, because as well, it constrained by a curve around it.
Ah, okay.
Mm-hmm.
Right. Okay, thank you.
All right, I would like to make a couple of considerations in general. I mean, I appreciate a lot especially the analytical part, where you investigated why certain things were happening and capitalized on those things to then further improve the design, which is a very good move in the limited time that you have.
This one?
When you analyzed and discovered which was the role of certain components in promoting certain patterns during the assemblage, right? Finding out that there were certain key aggregations, certain key components. Well, I would like to have seen this exposed and explicited a lot better in terms of presentation, focusing maybe a little less on the effect of the thing and more on the analysis data. I mean, but this is a little bit of a general consideration for, except for maybe something that Andrea and Saurabh showed in the first presentation. I understand that it's really hard and peculiar, but my obsession in this case is exactly into trying to expose a lot the fact that we are dealing with data and information here. That also comes in the form of architectural qualities at some point, or engenders architectural qualities. But there is also this entire dimension, which is exactly the dimension in which computation operates, that it's too often left behind and not explicited enough. I mean, showing exactly what set of rules determine the behaviors that you've chosen, the highway behavior. Exactly the question that Yanis was posing before, right? Mm-hmm. If in the presentation, I mean, let's of course take away all the consideration about the time constraints. I know them very well. Don't worry, I'm not putting the blame on you. I'm just making the consideration that exactly because of the time constraint, when you are forced by this, let's say, dire limitations, your mind goes to what you instinctively consider more important. And I want you to reflect on the fact that you instinctively consider more important to add a spaceman in Photoshop in the render, rather than, it's not a critique, I'm just stating the facts, okay? At some point, you decided that it was more important to think about decoration than something that was, so it's not, hey guys, this is the blame on you. No, I think reflect on that, because there is a dimension that we were trying to explore here that it's really forgotten, but it's really central and crucial to this exploration. So for your let's say following endeavors and adventures in the architectural field, keep that in mind, keep that into consideration. Because that, of course, I mean, the communication of the project, the effect, the perceptual part, all have their very important role, and I don't want to dismiss that. It's just that put this other thing into the balance of things.
Yeah, thank you.
Because that is just as important.
Yeah,
all in all, yeah, the other consideration is exactly on the perceptual side. It would have been a lot interesting to navigate this from within. And yeah, I appreciate the view from the outside, but navigate it from within and seeing the space. Personally, giving the spatial distribution model made of these highways and ramified and dendritic kind of result, it looks a lot to me that this has the possibility to be a space hub, where you have like spaceship coming and going, exchanges of things. It's like a spaceport, something like that. Because the structure is very much like its structure and ramified and articulated exactly like an interchange, like a nexus of things. It's made for the exchange of things. This that you have here. So it could have been also an interesting post-processing strategy to locate all the possible hubs and bays for ship to approach, and see, okay, then we have all these distributions, and then knowing, analyzing the internal path, what are the most important nodes in the structure, have this sort of analysis. That's cool. Can you go to the slide where you're trying to design the final geometry? I think it's the last slide, probably.
This one?
Yeah, this one. Can you zoom in on the object attempt? Okay. If you can, or otherwise leave it like that. It's not big deal.
It's working?
This one, yeah. Leave it like this. Leave it like this. It's okay. That's not the problem. Just a word of advice. If you design something that is like this, actually, can you see my sketches or not? I don't know.
Yes, yeah.
So it disappears. I don't know why. I do a sketch and after a while it disappears for whatever reason.
I can't see the sketches.
Yeah.
You can see it.
No,
Yeah.
I can't.
Okay, because I am sketching, but then after like a few seconds, the sketch disappears for whatever reason. Okay, but let me try again. Let's see if no. Okay, I'm not able to sketch. Now, what I wanted to say is, okay, no sketching. I will just try to do this explaining vocally. The thing is, the design of the opening that you've done is a dead giveaway to modularity, because you exactly put a declaration of modularity. So there is no possibility for a larger pattern to emerge. Remember the discourse on Truchet tiles? So imagine the most elementary Truchet tiles, which is half of a square, right? So what Truchet did, okay, let's have a half square black and half square white, and just work with the rotations. And then you have all these emerging patterns, because at some point, the black areas can, when you put them one next to each other, you lose the perception of the single triangle, and then you can have another larger triangle or an entire square, or even more complex pattern. But imagine if Truchet, instead of just coloring these two things differently, would have drawn a circle in the middle of each of those triangles. And then you try the same approach of Truchet. All you could see would be like a matrix of circles and no larger pattern. Okay, you get what I mean?
Yeah.
No, actually, I didn't.
Yeah.
I should sketch it, but the sketches are going away. So if you look at the through shape tiles example that I showed you in the day one, remember those patterns?
Yes.
Made of, yeah, they work because they are able to build larger patterns when you put one next to each other just by simple combination of rotations. But
Yes,
if instead you put a very recognizable figure right in the middle of each tile, you lose all this possibility to build larger patterns. Okay, so if you put the objects that are perfectly recognizable in themselves, in their figure, in your component, then that object will always be a dead giveaway that you have a module there. It's like putting a flag in the module and say, okay, this is a model, this is another model. So if instead of working with those, you work with something that connects to the connectable part of the object, like simple strip cuts that arrive to the connectable part, so that eventually those strip cuts can connect to other strip cuts in the next component and then form a larger strip cut. Or this sort of thing. So cleverly work with the connections in terms of putting something that is incomplete in the object that can be completed by the next object. If it eventually gets connected in a certain way. So you work by combination of connections to create larger patterns in the ensemble. Instead of, if you place it recognizably in the middle, you know, that's some basic principle of tileability, like how a figure can be tiled. Instead of being the same, you just make the extreme be able to connect to each other, but then the figure can change inside. Okay, that was it, but yeah, nice job, nice work. Oh, Jan had to go. I hope he's back.
Yeah, I'm back. Yeah.
Okay, good, because now it's your turn and you're the last group of the day.
Cool. So Alexander will share the screen, I think, and we have a small introduction. We don't have much reference images, but maybe we can talk a bit about the topic. So our point of interest was actually two systems. I had in mind a sort of scaffolding structure, and Alexander had in mind another structure which he will talk about. And we thought about combining these two systems into one system that could work together. And also, I want to say that I really appreciate this sort of setup or workshop around the topic of assemblage, because when I started with Grasshopper, as probably many people, we started with parametric design. Then I explored a bit of swarm logics. But to me, like this approach really goes into how things are built, how things are connected. And I think that really fits to a lot of things about construction, about inner logics, which I would like to try to explore and also use in my project. So really happy I could work with on this topic. And yeah, maybe I can hand over a bit to Alexander. What was his reference?
Yeah, so thanks. For my part, I've been really interested in this kind of discrete madness for several years now, and I've been through that with the work of Yanis Xenakis, who brought a completely new way of considering the sound as a texture, as a material made of a lot of small discrete elements that evolve in the time, and by now he can just create his own sound by dealing with densities and the height of the sound, etc., of microparticles. And I think that it's really relevant to see architectural design and with the help of computation to go through this kind of techniques. And so yeah, the thing that's interesting with computation is that there is basically no scale, and so you can work at different scale with the same processes. And so this is more or less what we try to do with Jan. So we worked at two different scales, one micro scale and some more micro scale. And yeah, so it's with the same principle that what we did in this workshop. And so yeah, now maybe Jan will begin to talk a bit more about the macro structure.
So my idea was to generate sort of a space holders for the smaller structure happening inside. So I came up with a very simple two volumes basically, which can somehow connect together. So we defined the connection types, the heuristic set. And basically tried to make a space that grows, but also is coherent. So here you can see how the heuristic string that I chose actually does this. So the combination and the ratio of the triangular and rectangular elements does this sort of wally structures or slabs, which are later a little bit more articulated. So I really like that idea for the notion of, let's say, scaffolding. So I can imagine that the wireframe of this structure would be my columns and ledges and braces for the scaffolding. Yeah, so I chose this structure to work on. Maybe we can check another slide. And then actually to connect the structure of mine to Alexis, we chose the post-production technique of shortest path. So we pick some points from where to get where the fastest way. And these places we wanted to articulate more in detail. So you can see in red the shortest path, and around it's actually sort of extra geometry, which is populated on next to the macro scale geometry. So here you can see that I could reference, let's say, the connection lines with some, I could add extra geometry around it, which can work as a, for example, extra structural elements or stuff like that.
And yeah, the goal was here to go gradually from quite light density to a very more compact density, and so this is what I will the step that I will show you now. So it was kind of a transition between the two scale, between the macro and the micro scale, if I can say micro, but. So the idea for this microstructure was to work with standard like PVC pipes, and that are that gives all the some standard connections possible. So here you see all the elements that were used, and here just a very small sample of the heuristic. So in this part of the project, I used 3 different size of pipes. So one side that is that has a diameter of 10 centimeter, another one that is the double, and the last one, the biggest, which is a diameter of 40 centimeters. Then, yeah, the goal was to really interconnect all those pipes using those connections, and to get a very compact and dense structure with some movement inside. So yeah, here you see a bit more about the process. So I used 2 constraints, basically. The first one is a container that in which the pipe can involve, and I cannot go out of this. Yes, this can give the overall shape. And the other is a vector field that is influenced by a curve that you can see. And so that way I can more or less manage the orientation of the pipe. So sometimes I can get some more chaotic assemblage, but the interesting thing with that is that I can always have some clean, if I can say so, but some clean interfaces at the edges. So what you can see here and here, the pipes always arrive in this direction, but in the middle here they are well aligned, and here it's a bit more, yes, chaotic with some other angles, etc. This gave me the possibility to work like in really 3-dimension space, and to really have this difference of density of chaotic organization, but at the same time with quite a regular structure and some patterns that can emerge when you give a closer look at what happens in those forms. And so then here is where we combined our approach. So you can see the structure that Jan designed, which is very light and with some very nice visual effects. Maybe Jan could show you later some videos that he did about this structure. And so we have this interconnection with those very dense and compact pipe structure that gives some direction, and yeah, that can give you a sense of space into this great 3-dimensional structure. So now you can see, sorry for the context, we are a bit more on the spatial station side maybe, but yeah, here you see with the human of the scale with the human here. So yeah, this very big and light structure, and this this huge pipe that goes in. And so here you see a bit more about the moire effect that Jan was looking for in his researches.
Yeah, maybe I can share the screen with the small video I made. Yeah, so I was looking for this. I'm not sure if you can see it, but this sort of moire effect when lines overlap. So that was also the visual intention, and I wanted to explore if that works with this geometry, and I wanted to create more patterns with the geometry and maybe also play with other stuff like field to make maybe more spatial macrostructure. But yeah, that's where we got. So yeah, that's it. Maybe I stop the animation now and we can come back to the presentation.
Yeah, well, anyway, it's the end.
Yeah, that's it.
Okay, thank you very much. So I'm gonna give words to our guests.
Should I go? Anis, do you want to go?
Yeah, I can start. Do you want to say something? I mean, as you.
Okay.
Okay, I will start. I will start. Sorry. We can go on forever with this, I guess. So no, I think it's very interesting work, and I think you have some very intriguing, also in visual terms, structures at the end that are, I would say quite new to me in this context of discrete aggregation, especially with this kind of like space frame and which is filled by these very dense volumes. So that is quite new, I would say, as a grammar, and so that is very interesting. But I really appreciate this idea of multi-scalar aggregation, and that is something that for sure is intriguing, and in this case you already have some very pretty neat results. I was just wondering if there would be, I mean, if you see it as a possibility, right, to have this coming from like a single system, not I mean, by means of kind of recursion procedure or like feedback, and not as one system which becomes some kind of guiding area for another, which is interesting, not like saying that dismissing this approach you had, and for sure I understand it was also a way to work in two directions and unite things. But have you thought about the possibility of having like one system that is, maybe because the components have different scales, or maybe because of the capacity to assemble, they can work like as both containers and microstructure? Is it something that you have thought about, or that could be developed?
Actually, we pretty quickly get into the approach we presented you today. First, actually, yeah, we just wanted, both of us had some quite specific topics that he would develop. And so, yeah, it was basically what connects us is that we work with linear elements. But otherwise, yes, it was this was a way to separate the work, and also to yes, have a complementary work. But we didn't really thought about the way to get this different kind of scales with the same element, like a fractal or a recursive technique, like what you can say. And I would say that actually this wasn't really my in my personal point of view, this wasn't really the direction I wanted to take. I was really interested by this. Actually, I had really this kind of okay, this kind of drawing in mind. If it want to work, no, it won't work. So sorry. If I can. Yeah, but yeah, this kind of global movement, and that is defined by a granular approach with all of these small particles. This is the kind of stuff I was interested in, and on Jan references were more about some very light structures and scaffolding systems with this. Yeah, it wasn't the latest references that he had. But so, yeah, of course, we could have, for instance, take the scaffolding system and recursively divide all the cells at a very dense approach to get this kind of density we had. But yeah, this is just another approach we decided to take.
I mean, you just finishing quickly, you can think of it as like fractal-like, but it can also be of, I don't think that's the most interesting way of thinking about it. You could also see it as a way, you know, if you do like, you have a system that with multiple connection options and opportunities. So if you take the stress and you divide it each cell, of course you are going to get something that is in a way very repetitive and very invariant with the scale. But I think we could also think of a way as introducing variation and maybe enabling some heuristics as you kind of subdivide it. So I'm not really thinking as a way of taking a large unit and dividing it in places, but maybe, you know, as a way to have some kind of initial attribution of elements, and then you switch to another kind of resolution and you introduce other heuristics. But this, I mean, this is just some thoughts, right? The work is very good, and really, I mean, I'm really impressed. I really appreciate it.
Thank you.
Well, I think it's an impressive work. Really, I think it's really interesting. It seems like a Center Pompidou on steroid to me. And no, it's the images are really nice. I was wondering what would be a possible functional implementation of this kind of system. For example, the work on the pipes. It's interesting because you can really see the field that you use in order to inform the system. Is not clear to me if the variation between from a small to large pipe is something that you can control and how you are driving it, or if it just emerged according to which component is you had before. So I'm thinking what would be a possible functional use of this approach, if it can be something structural, if it can be a system of path or road for I don't know, for cars or any vehicle, or just a system of pipes in order to drive some fluid or something. I'm wondering which are the properties of this object that make it useful for some practical application, because aesthetically it's really interesting, and I see that there are some properties, but I'm just wondering how we can quantify them and use for a proper design of something.
Actually, so for the dense pipe structure, I really wanted to manage quite precisely the density of the pipe. So I wanted to get some areas where there were really few pipes or some thinner one, etc. But it came that it was pretty hard to do with the current state of the tool we were using. So in the future, I think I will get a bit more into the code, and I will follow for sure the evolution of this tool. But yeah, and so now the repartition of the big pipes or small pipes is no, it's pretty random, but actually we can see that the big pipes are appearing where where the vector field has a 45-degree angle more. because there is only one small connection that has a 45-degree angle and one connection for the big pipe that has 45-degree angle. So he can choose between two connections, and on straight lines he can choose with a lot more connection for the small diameter. So there is more chances that he takes the small diameter. But of course, I would have loved to go deeper in the rules that can prioritize one pipe or another. This is what I tried to do, but within this 3 days work, I couldn't manage to go further than this. And yeah, about your other question, the advantage of working with linear elements and this kind of nodes and lines is that it's pretty easy to do some finite element analysis, like with Caramba or any other software to simulate this. But on the other hand, I don't see now, with the current state of the tool, how it would be possible to take the result as a new entry for the process. So it would be kind of a machine learning, I guess, with the evolution of the global evolution and the connection and the repartition of the elements. But I think you should have to start the process again and again and again and learn which kind of connection are the most useful for the goal you're trying to achieve. Or I don't know, maybe I'm mistaken, but yeah. But for sure, it's something that could be done, I think.
Yes,
and
so
actually, the idea of doing this came from a project I was working on as a freelance for a construction company that has some research and development department, and they developed this technique where they were assembling some very standard PVC pipes, and they were filling it with concrete. So they could do some structure. They did some bridge with it, some small bridge. But yeah, it worked, and the evolution of this was to use some fiber reinforced concrete. So this is kind of an evolution that is possible, maybe. Well.
Yes, definitely.
Maybe I can add also something to the questions.
Sure.
What I really appreciate is that we actually could really work together on the same thing on different levels simultaneously. And I think this tool is really good for that, because you still can reference to every point in the design, and you still hold the overall, let's say, address book of all the places. So we could easily actually communicate it, although we had to video call and stuff, but also, like, that's my answer to why those systems are dislocated. They are not merged together that much, but I think that's also in a real life, like in a building, there are many systems which sort of are not physically related. They are not physically connected, or on only small points. They have different logics, but they need to be combined in the space. So actually, I really appreciate, like, this work together, that we could work actually in the same, with the same tool on different levels of scale. So yeah, that's what I learned from the workshop most.
Yeah, thanks, Jan. Well, personally, I think that you've done a really impressive work with this thing in the days that we had for the workshop. One thing that I would like to add is that yeah, the important thing is the way the process is managed, the way the workflow is structured, has the advantage that at any point you have an entire structured data regarding what you are building. I mean, one of the most important parts is the one that you are not seeing right here, which is the structured data, the topology, that it's always preserved. So at any point, I mean, you can backtrace the analysis on this thing that we are seeing and have the location and connection of every part with every other. So at any moment you can say, okay, let's see how this thing manages flow, for instance. You could do that because you have a data structure that doesn't need to be reverse engineered, and you can, I won't say really easily, but certainly more easily than if you didn't have that. You could, yeah, relatively easily feed this or open it to interoperability and a lot of other things regarding BIM processes or anything that pertains that. So yeah, I know I am obsessive about it, but I think the most important aspect is still the fact that you're organizing information on a spatial level. No matter if you decide to instantiate it at the scale of the constructive element, at the scale of the piping, at the scale of the spatial unit or component, the constant, the underpinning constant is the fact that you work and build an open-ended structured thing. And that's the main quality. I really appreciate, I would like to make a general commentary right now because, I mean, all the projects that have been presented have been very successful for the workshop sake, for what were at least my intentions when I decided to do this workshop. So I would like to congratulate collectively all of you for the efforts that you have done, for the results that you have achieved in these few days, for the fact that I threw at you something that it was also a lot experimental, incomplete, work in progress, but still you managed to dig through and did something very, very interesting with it. And I'm also really impressed by the variety. So I'm really happy that I didn't force on you the perspective that I had in mind at the beginning, because that paid back a lot to me in terms of results. So I'm really, really happy to see the heterogeneity of the results. In some cases, it looks like some of the results are coming even from different workshops. If you look at it, that in retrospective, and you didn't expose the process. So to me, that is a quality. So I'm very happy. The only thing, I would like to also to stress out the fact that, especially for those who have to work in couple, double praise, because you have to work in team at a distance, in remote, with all the difficulties, with all the other difficulties of this. Because during a workshop, I mean, the fast interchange of ideas when you are in present, you know how it is. It's a lot different. It's a lot better. So it was also an extra effort from your side, and I really appreciate that a lot. Believe me, a lot. Also because I suffer really, really, really deeply about this condition of being permanently Zoom connected, permanently at distance. I mean, if this was like an in-present workshop, now I would like wrap it up, and we all go for beers until late night. Unfortunately, we cannot do that. I mean, that is the thing that really, really sucks the most about doing the workshops in remote. That is really, really the worst thing about it. Well, guest critics included, of course. But not that you suck. That the thing that sucks that we cannot go hang out and have a beer. That's the thing that I was trying to say. So if the guests do not have maybe any final comments or impressions from their side? Would you like to say something?
I mean, my final comment is that I think that all the work are actually quite developed for the time that you had. Probably it was because it was embedded in the strategy, because the students, the participants were just able and skilled in order to develop those projects. But I think that we saw something very interesting and also inspiring. Maybe they're not develop ideas, but I mean, they can inspire some possible future development according to this strategy and this design approach. So I'm really looking forward to what is going to happen to the tool that you are developing, Alessio, and also to the next result that we will see starting from this starting point. And congratulations to all of you.
Thanks, Alessandro.
Yeah, I mean, I think it's, as you said, it's also interesting to see the different scales and visions that were developed. And so this is something that I really appreciated also in the projects. So some are, more like kind of, you would say at urban level, and some are like more speculation structure. You of course have architectural projects. I think this is very telling of the potential also of this tool and this approach to, to solve questions of space, but at like from different perspectives, like from the global organization or from the kind of more structural. And so that was really inspiring to see these works. And I would also congratulate you all, because in 1 week this is pretty impressive. So yeah.
So okay, thank you again. First of all, thanks to our guests, Alessandro and Yanis, also for a very insightful commentary to the projects. I'm really happy that you could make it to these presentations, and I hope that the participants have gathered a nice experience, or they had a nice time with me during these days, as I had with them. I really appreciated my time with them these days. And so, time to wrap it up for good this time. Guys, thank you very, very, very much for participating, for delivering, and look alive, because remember, I'm gonna send you an email in a few minutes with what you have to send me. I mean, it's things that you should already have, so there shouldn't be much extra effort. But if there is, I mean, just this really little tiny bit of things, and then it's over. And if you want to go on with what you were developing during the workshop and would like to have some consultancy on it, please don't mind forgetting my address, my phone number, and everything. And we never knew each other. No, I'm kidding. Of course, you can write me at any time, and I'll see what I can do. Okay.
Thank you very much, Alessio, and also a huge thank you to you for the whole week, also teaching everything. And I think it was a big pleasure for me. You should come to Bartlett and teach there. I think they could actually learn something.
Wow.
Yeah,
I'm flattered. I mean, come on.
Yeah, you should really do this. Yeah,
guys, remember your.
But it was really cool for me to learn this tool and everything. I enjoyed it very much. And yeah, thank you very much.
Thank you, Nora. Thank you very much.
Thank you,
guys. I know I would like to have a single word from any one of you, but we are running also a little bit out of. I'm running a little bit out of time. So consider the fact that I already received everything that you want to say, even critiques. I mean, not necessarily praises. But if you want to add something, or you have something that you think is valuable to say about the workshop, I'll be curious to hear it or read it. If you want to write any consideration or any way you think that what I showed you could be improved, I'm really open to that. It just contributes to the collective progress, I think. Also because sooner or later I'm going to release this to the public. So let's see how we can make it better. Right. So This time, the third time's a charm. Let's wrap it up, and a big round of applause to everybody, every one of you. It works if we all do it. Otherwise, it's just me alone, like an idiot. Okay, thanks. Open your microphones. Open your microphones.
Ah, okay.
Unmute. Open your microphone.
Very good.
Thank you very much.
Thank you.
Thank you.
Okay, time to say goodbye to YouTube and say goodbye to our guests. And I hope we'll keep in touch, maybe through email or social media.
Yeah, of course.
Bye.
Goodbye.
It's been a pleasure.
Bye.
Architectural Machines
Bye.
end here. And goodbye to everybody. It was a real pleasure.